So we continue looking at cubic functions, all right? So this cubic function question came with a graph, all right? It came with a graph already plotted and everything. So the first question is saying that find the equation of a tangent to the curve y is equal to 1 plus 3x minus 3x squared at the point where x is 1 and y is 1. So in answering the first question, what you do is you first find the gradient function, okay? So our function is y is equal to 1 plus 3x, right? Then minus 3x squared. So what you do is you first find the gradient function of that, right? And if you want, you can write this in standard form of a quadratic function. So to be y is equal to negative 3x squared plus 3x plus 1. So now, if we find the gradient function, that means we're going to introduce calculus, right? But the differential calculus. So it's a dy over dx is equal to first find the derivative, right? So if we differentiate this function, it will be negative 3 times that 2, it is negative 6x, because the power reduces by 1. Then this x has the highest power of 1, so 3 times 1 we get a 3. In that 1 minus 1 we get a 0, so x to the power 0 we get 1. So if we differentiate that, we are getting this, all right? And with differentiation, a constant is always discarded because it gives a 0, all right? So my gradient function is dy over dx is equal to negative 6x plus 3. So I'm going now to use the point, because the next thing I'm going to do after finding the gradient function, I'm going to find the gradient. So now where there is x, I'm going to put 1. So for me to find the gradient, I'll say gradient is equal to negative 6, open bracket, 1 plus 3. So my gradient will be negative 6 times 1 is negative 6. Negative 6 plus 3, you get negative 3. So that's my gradient. So now, that is my answer for the first question. So I've managed to find the gradient. So but now I'm saying find the equation of that tangent. So we're now going to bring in the standard equation of a straight line, because the tangent is a straight line that touches a point like this one here. This is our tangent, right? That's our tangent there. Okay, so we're going to use the equation of a straight line. So y is equal to mx plus c. Y is equal to mx plus c. So I'll use those points. Where there is y, so that I find my y-intercept. Where there is y, I put 1 is equal to my gradient is negative 3 multiplied by 1 for x plus c, so that I find the y-intercept. So y is 1 is equal to negative 3 times 1 is negative 3 plus c. Then I group the like terms. I'm going to have c is equal to 1 plus 3. So c is equal to 4. So now I've managed to find my y-intercept. So my equation of the equation of the tangent will be now y is equal to, my gradient is negative 3x plus 4. That is the equation of the tangent. All right, that's the equation of the tangent. So I've managed now to answer completely this question. So find the equation of the tangent. So we first find the gradient. After finding the gradient, then we bring in the equation of the straight line, then find y-intercept. After finding y-intercept, we get to this point. All right, so we found the gradient by differentiating our function, then we got that gradient function. Then after we reach a gradient function, use the point that we're given at the point 1, 1. So we say where there is x, put 1. So it's negative 6 times 1 is negative 3. Negative 6 plus 3 is negative 3. That's our gradient. Then after that, I replace where there is m, I put negative 3. Where there is x, I put that 1. And where there is y, I put 1, so that I find the y-intercept. And I found y-intercept to be 4. Then I say y is equal to negative 3x plus 4 as my equation.